This is the first video in a new series covering the 7 basic quality control tools. These 7 tools form the foundation of process improvement in Lean and Six Sigma, and almost every quality problem you will ever face can be analyzed with at least one of them. Today, we start with the histogram. So, what is a histogram? In simple terms, a histogram is a bar chart that shows how often values occur within a set of data. It takes a list of numbers, groups them into ranges called bins, and shows you how many data points fall into each range. The result is a picture of your data's distribution. Instead of staring at a spreadsheet full of measurements, you get an instant visual answer to 3 questions. Where is my data centered? How spread out is it? And what shape does it take? Let us walk through how to build one. Step 1. Collect your data. You typically want at least 50 data points and ideally 100 or more for the shape to be meaningful. Step 2. Find the range by subtracting the smallest value from the largest value. Step 3. Decide how many bins to use. A common rule is to take the square root of the number of data points. So for 100 measurements, you would use about 10 bins. Step 4. Calculate the bin width by dividing the range by the number of bins. Step 5. Count how many values fall into each bin. And step 6, draw the bars. That is it. The height of each bar shows the frequency for that range. In practice, you will almost never do this by hand. Software builds the histogram for you in seconds, and I will show you how later in this video. What matters is that you understand what the picture is telling you. So let us talk about reading the shape, because this is where the real value lives. A normal distribution looks like a symmetric bell. Most values cluster in the middle and taper off evenly on both sides. This is what a stable, predictable process usually looks like. When you see this shape, it is a good sign. But not every histogram is normal, and the abnormal shapes are also often. A skewed distribution leans to one side with a long tail stretching left or right. This can be perfectly natural for some processes, like time measurements, that cannot go below 0. A bimodal distribution has 2 distinct peaks. This is a big clue. It usually means you are mixing data from 2 different sources, perhaps 2 machines, 2 shifts, or 2 operators. A truncated or cut off shape where the data stops abruptly often signals that parts were sorted or inspected before measurement. And isolated bars sitting away from the main group point to outliers or data entry errors worth investigating. Here's where histograms become powerful for quality control. When you add your specification limits to the chart, you can instantly see whether your process is capable of meeting requirements. Draw a line for the lower specification limit and the upper specification limit. If the entire histogram sits comfortably between those lines, your process is producing within spec. If bars cross or fall outside the limits, you are generating defects, and the histogram shows you exactly how much and in which direction. And when you pair the histogram with a process capability calculation, it becomes an even more powerful tool for quality. If you want to go deeper on process capability, check out the video on that topic. A few practical tips before we finish. First, always use enough data. A histogram built from 20 points can lie to you about the true shape. Second, be thoughtful about your bin count. Too few bins hides detail, and too many bins makes the pattern look like random noise. Third, never analyze a shape in isolation. Use the histogram alongside the other quality tools, especially control charts and capability metrics, to understand whether your process is both stable and capable. Now, if you want to build histograms and run a full capability analysis without touching a single formula, let me show you how to do it in SigmaDesk. From the Six Sigma Applications menu, I select Capability Analysis. In this simple interface, I paste my dataset into the spreadsheet, or I can load a dataset I have already saved in the platform. Here's my histogram visualized instantly. We can also see some Sigma calculations for the overall spread, which tells us how wide the variation is. The distribution here looks close to normal distribution. Now, to calculate the other important metrics, I will add my specification limits. I do this in the settings. I also set the subgroup size, which is needed for the CPK calculation. And now I can see where my mean sits and whether the process is centered against the specification limit. And in this case, it is quite well centered. That covers the histogram. In the next video, we will move on to the second quality control tool, the check sheet. If this was helpful, do not forget to like the video. Also subscribe so you do not miss more similar content, and I will see you in the next one.